Hi, I'm Rachel. I'm a PhD student at the University of Washington, and today I'll be presenting our work on AI-assisted causal pathway diagram for human-centered design. This work is in collaboration with Donghoon Shin, Rosemary Meza, Predrag Klasnja, Lucas Colusso, and Gary Hsieh. The primary context of our work is human-centered design. Given a specific context, designers need to think about ways to resolve specific issues. For instance, they may need to redesign a Metro mobile app to encourage people to take the bus instead of driving to work. And as they brainstorm ideas, there's a critical part they need to think about. That is, the use of theory and evidence. Prior works have suggested the benefits of using theory in design practice. For instance, theories can help suggest ideas during brainstorming. They can help designers choose which designs to prototype. They can help inform study design during evaluation stage, and they can also help support communication with different stakeholders. But research and practice gaps exist. The question is, can designers effectively use theories in practice? Prior works have suggested that it's difficult. First of all, designers are often not trained in relevant domain, so understanding and using knowledge in a theory-driven way can be difficult for them. More importantly, it's often unclear how to connect theoretical insights into the real world. Designers may be overwhelmed with evidence details, they may not know how to use it, they may also overlook some evidence, coming up with ideas that deviate from their original design goal. To address this, we introduce CPD, that is, the causal pathway diagram. CPD has been used in implementation science, but could be a great tool to facilitate evidence-based ideation. In human-centered design, it's important that we have a good understanding of people so we can design the right solution to address the problem. CPD can help with that by synthesizing microtheory, which is theory specific to the domain, to make sure design solutions actually address the issues they tackle. Additionally, CPD can be applied across different stages of human-centered design and form the design of strategies, support brainstorming, increase the impact of existing strategies, and so on. CPD contains multiple components, including the strategy, mechanism, barrier, proximal outcome, and distal outcome. These components represent how one would rationalize the way a strategy resolves the design outcome. For instance, if we look at the example here, if we want to achieve the outcome that more people take the metro to go to work instead of driving, the first thing we need to think about is what's the earliest sign of change. One possibility that we fill in as the proximal outcome is increased ticket sales. In order to achieve that, there might be some barriers we need to pass. One could be people are concerned that the metro does not follow the schedule. So then if we continue thinking backwards, one possible mechanism to address that barrier could be people will need to know ahead of time of accidents. And what would be an actual action to do that mechanism? Then we can have the design strategy that we update the metro schedule on the app every 2 minutes. But as you can see here, CPDs are really complex artifacts to work with. To help people more easily integrate CPD in their workflow, we designed an interactive diagramming plugin. The plugin is hosted on Miro, an online collaborative whiteboard platform. It uses large language model to streamline CPD generation, helping designers better navigate the ideation process. Next, we'll introduce some of its key features. In the Components feature, users can drag and drop components of CPD onto the board. They can edit and connect the elements to form a CPD pathway. As you can see from the example here, the user is trying to create a new barrier component, enter the element, and connect it to the distal outcome element. In the wizard component, we provide users a guided step-by-step process to help them brainstorm components of CPD. As you can see, we start with the desired outcome, then we prompt them to think about the barrier. During each step, we ask a large language model on the backend to use previous inputs to suggest possible next steps. Users can choose one of the suggested options, or they can edit and write their own if needed. And at the end, after they've brainstormed all components, they can drag and drop, and a completed CPD will show up on the board. In the brainstorming feature, users can think more closely about the content of a specific component. For instance, if someone wants to brainstorm the proximal outcome, this person may already have an idea of what's possibly before it and after it. So this person can simply select what elements it could be. In this case, could be the barrier and the actual outcome. And they just need to input the content in the corresponding field. And once completed, they can just drag and drop onto the board. Then there will be a CPD generated with large language model recommendations of 5 different possible proximal outcomes, demonstrating a diverse set of options. When we talked about the possible use of CPD throughout the entire process of human-centered design, our work specifically explores the early stages of design. We asked the following questions. How do designers use CPD in the early stages of human-centered design? And how does the plugin support practitioners in designing with CPD? To understand these questions, we conducted usability testing sessions with 20 UX designers. In each session, we asked participants to complete 2 10-minute design sprints, one without using our tool and one using our tool. For each design sprint, as shown here, there is a design prompt, a user persona, and a scenario explaining the issues the persona was encountering. Then participants would use CPDs to ideate possible solutions, and after completion, we also asked participants to rate their experiences. Upon analysis of the sessions, we highlight the potential use of CPD in human-centered design. Designers pointed out that CPD helped them establish an effective and guided design process. That CPD helped them think about relevant constraints up front and helped them focus more on the desired outcome of the design. Additionally, CPD was able to support both divergent and convergent thinking. Participants talked about how CPD offered a way to expand ideas in different directions through branching, while maintaining a structure so that it's easy for them to do strategic prioritization. They mentioned that the structure of the CPD served as a guardrail to keep track of why components created, and thus helped them understand which ones to choose over the other. In addition, participants mentioned how CPD can serve as a communication tool because it offers structure and order. In addition to the use of CPD, we also tested how the use of our plugin impacted designers' way of generating CPDs. Our results revealed that participants had a positive attitude toward the plugin. They thought that it helped them more easily generated components of CPD, helped them more easily brainstorm ideas. Additionally, we found that participants created more pathways in their diagrams using our plugin. For instance, in this example showing a participant CPD without using the plugin, we can see that people only thought through one barrier, which is people are concerned that the metro does not follow the schedule. In contrast, when our plugin was used, in addition to the barriers of concerns about inconsistent schedule, the participant also thought about lack of confidence in public transportation. Additionally, we noticed for the concern about inconsistent schedule barrier, the participant was able to think about multiple mechanisms as well. This shows that our plugin helped participants think more about diverse options. Our qualitative results corresponded with the quantitative findings. We found that the plugin provided the framework details in an easily consumable way and guided users through the process of creating a CPD in an orderly fashion, allowing participants to focus on the design task and thus alleviate their cognitive workload. Additionally, the use of large language models helped them more easily articulate their existing thoughts using expressive and direct language, helping them free their energy and focus on creative thinking over articulating ideas. Although participants were generally positive about the AI suggestions, they did mention that some of them may be generic, especially when users do not provide sufficient context information in existing elements. And some participants mentioned the need for more evidence-based AI recommendations. They mentioned that they need to actually understand the meaning of a suggestion and why it's being recommended before they could confidently use it. So that's why they want more information about the specific piece of evidence supporting the AI recommendations. Overall, our results highlight how CPD can facilitate both divergent and convergent thinking, and how it can serve as a communication tool. We also point out how AI can make diverse recommendations and thus could possibly reduce design fixation. Despite the usefulness of our tool, participants ask for more context support. Our hope is that in the long run, we can build up a repository of developed and experimentally evaluated causal pathways to power our recommendation to designers. In the meantime, it's also useful to think about trying different prompting techniques to further improve the accuracy of large language model recommendations. Of course, more work is also needed to streamline integration with user research. Overall, our work integrates CPD into human-centered design and explores the use of AI in facilitating more evidence-based design. This is the end of our presentations. Here are some references that I used. And thank you so much for listening. And please feel free to reach out if you have any questions.